Hi class, we're going to take a look at these problems, and in this set of problems we're looking at the slope of lines. And then well, for the first one they're giving us the actual sketch. So the value of m is equal to the rise over the run. And then we have to be a little bit careful because the actual slope is actually well, the actual unit it's in terms of twos. So the units from this point going up, you're gonna do, well, that would be 2 and then 4. So this is equal to 4 over, and then it goes all the way to 10. So 2, 4, 6, 8, and 10. And then what I'm gonna do here is I'm just gonna reduce it. So this is going to be 2 times 2 over the values of 2 times 5. And then you can see a common factor of a 2's. So the slope in reduced form is equal to 2/5. So all of these problems, they're going to want us to reduce the slope. In this case, careful here because the units are going by 2's. But we end up with 2 over 5 after we reduce the value of the slope. Let's take a look at example 2. And same idea, this one is going by 2's. So as we write the value of the slope, we have to be careful on this one because the actual value of the slope is negative. This line is decreasing, so it's going to be -2 over, and then technically it's going by 2, so 2, 4, and 6. Which is equal to, and then we'll reduce it. So in this case, this is -2 times 1 and 2 times 3. And we can cancel the 2's. So we'll end up with -1/3. And that's actually it for figure 2. Let's take a look at another one. Okay, so this is an easy one. So by definition, the slope of a vertical line is undefined. So in this case, the m is going to be undefined. And then the idea here is that as you're looking at the rate of change as the line goes to the right, well, this was not changing because you're given 2 coordinate points that happen to be the same axis. So it's never going to the right. So remember that when we talked about slope, well, this is technically a line that's decreasing. It's going down at a rate of 1/3. And then technically this one is increasing. It's going up at a rate of, well, 2/5. So technically 2/5 towards the infinity. So figure 3 is not going to the right at any rate. So we define it as undefined. Let's take a look. In this case, figure 4, it's a horizontal line and it's automatically 0. So by definition, the slope of a horizontal line will be 0. The slope of a vertical line will be undefined. That's actually it for the first set of problems. We're going to take a look at problem B, and in this case, they're giving us equations. So let me just write out here that if you have y is equal to mx plus b, m is equal to the slope. But it has to be in this format. And then also, if you have a line that happens to be y is equal to b, well, in this case, automatically, our slope is going to be 0. So a line that is just in y is equal, it's going to be a horizontal. And a line that it's given as x is equal to a, it's going to have a slope that is undefined. So that would be these two. So this would be, if they give us the equation, well, in this case, actually, wait, sorry, this would be y is equal to 4. And the actual equation of this one would be x is equal to 3. So just take note of those formulas, which we will need. And if you take a look at the first problem, well, in this case, the number that multiplies the actual x's is equal to 2. So the slope of this one is 2. there's nothing to do on that one. It's basically just identified the value of the slope. If we take a look at the second one, well, you technically have 1 times x, so the value of m is equal to 1. The slope is 1. Now, notice the difference on the next one. You technically have a 1 times the x. So in this scenario, we would say that the actual slope is equal to -1. Let's take a look at the next one. You have x is equal to 9, so in this case vertical. So automatically we would say that m is equal to undefined. Let me write it better. Next one, y is equal to 7. So we're going to have a horizontal line. So automatically m is equal to 0. Let me go to the next page. And on the next page, what you technically have here is 1/3 times the values of x. So for this one, m is equal to 1/3. So the slope of this one is equal to 1/3. Notice that when we're talking about the slope, we don't put the x, it's just the number or the coefficient. So on the next one, you technically have -2/3 times x. Therefore, you could view it as the value of m is equal to -2/3. Okay, so we have a minor problem on the next problem, and that is it's not in mx plus b. So we don't have it in this form. So we're just going to do a little bit of algebra and rewrite it in that form. So let me just distribute the 2's, and we would have y minus 5 is equal to 2x minus 10, and then add the 5. So we would end up with y is equal to 2x minus 5. Then from here, we can say that m is equal to 2. You could have seen it from the beginning of it because the only number that's going to multiply your x's would be the 2, and there's no other x's. But technically, we don't actually make that statement until we have it in mx plus b. In this case, that would be the proper equation to quote, and the slope happens to be 2. Same idea with this last problem. What I'm going to do is I'm going to subtract the x's, and you're going to end up with the values of 2y is equal to -x plus 10, and then do a division of the 2's. And let me just rewrite it in mx plus b. So in this case, y is equal to -x over 2 plus the values of 5. From here, you can see that m is equal to -1/2. Remember that it's the value that multiplies the x's. So if you rewrite it as -1/2 x, you will have the slope of the line. So that's actually it for these problems where they gave us equations and they just wanted us to find the value of the slope. Remember that you're always looking for this main equation, in this case the mx plus b. If it's given in that format, we're looking at let me highlight. So we're looking at this main equation. There's another problem here that they want us to provide a sketch, and all you need for this one is, well, they want us to provide a graph. They don't tell us the specific value. So a positive slope, it's going to be any line that's going to be increasing. In this case, this is your sketch. A line that is going up, and remember that you read it from left to right. Negative slope, it's a line that's going to be decreasing. So for the first one, m would be a value greater than 0. For the second one, m would be less than 0. Zero slope, it's referring to a horizontal line. So in this case, any horizontal line would be fine. This would be m is equal to 0. And then the last one, they want an undefined slope. So this would be sufficient. A vertical line. And that's actually it for these problems. They don't specifically tell us any values. So we're just looking at the actual position of the slope. That's actually it for this video, you guys.